Okay, so say I want to write these three in logarithmic form. So again, these are exponential. I can tell they're an exponential because they have exponents. If I want to write them in logarithmic form, well, again, log is my exponent. So I'm going to say x equals my exponent equals log. The base of my exponent was 3, so the base of the log is 3. Then of 7. That middle is what it equaled. So this here, that thing that inside of it is kind of just what it equals. So if you can get that the log equals the exponent, so x equals log, and keep the same base, and kind of whatever's left over is what is inside the logarithm. So let's do it again. My exponent is 2. So 2 equals log. My base of the exponent was x, so I'm going to have base x. And it was equal to 9, so of 9. Do it for the last one. So x equals log, because x was my exponent. Base was 2, so base stays 2, of y. And let's look at this last one real quick. This last one I just saw for the x, the variable in play. When I've done that before, I've actually been finding the inverses. So if I have a function, f of x equals 2 to the x, and I want to find the inverse, I would literally do this. I would change my f of x to a y. I would solve for the variable in play, so I would have it be x equals, and then I would write it as f inverse of x equals log base 2 of x. So exponentials and logarithmics are inverses, which means that my domain and range changes. My domain of my exponential is my range of the log. My range of the exponential is the domain of my log. It means my x and my y's switch, so it's one good way to remember how these things are graphed. If I have an exponential, and I want to graph an exponential, it has a horizontal asymptote, and it has a point 0, 1. If I'm going to graph the logarithmic, that's going to have not a horizontal asymptote because my x and my y's change. It's going to have a vertical asymptote still at 0, so still at the axes. Instead of a point 0, 1, my x and my y change, so it's going to have a point 1, 0. Kind of follows, though, the rest of it. To the left, it follows the asymptote. To the left, it follows the asymptote. To the right, it goes up. To the right, it goes up. Just goes up slower on the logarithmic one. Okay.